Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, I am going to discuss one very interesting requirement which I recently got in our project. And that is data analyst team or business analyst team will be making an insert query in our AWS RDS Postgres system. And based on that particular insert query, we need to trigger one Airflow tag. So how we can solve this particular business requirement, that I am going to explain today in this particular video. So here if you see, the approach is pretty simple and this particular pipeline is showing that particular flow. Here insert query will be making, and using a particular setup from Postgres, we can trigger our Lambda function, and then the Lambda function can easily trigger our Airflow job based on Airflow REST API. Now this particular segment, that is Lambda to Airflow diagram, this I have already covered separately in my previous video. The prerequisite link I'll be sharing in the description box. You can check from there. And even I have created one particular Medium blog on the same, that is breaking the polling barrier, accelerate data processing using push-based architecture with Airflow and Lambda. Because Airflow mostly works on poll-based manner. For example, if in any particular S3 location, if file lands, then you want to trigger your Airflow tag. Suppose that kind of problem you want to solve only using Airflow, then what we have to do that with certain time interval, we need to continuously poll that particular S3 location. So this is polling barrier, right? Unnecessarily resources can be wasted most of the time in this kind of architecture. So if we can make this push-based, that as soon as the file lands in S3, Airflow drag will be triggered in event-driven manner. That is basically optimized architecture. And that time, obviously, we can take help of AWS Lambda and Airflow REST API. And this particular pipeline I have explained that when the file get landed in S3, from there Lambda will be triggered, and then Lambda will call our Airflow job using REST API. And the Airflow job can launch any other compute instance, that can be EMR or EC2 or AWS Glue or AWS Batch, etc., and apply the transformation based on our business requirement, right? So this Lambda to Airflow trigger part I am not explaining, but rather our focus should be on this particular part, what we are going to explore newly, that how from Postgres we can trigger our Lambda function, right? And here we are having one particular AWS documentation which explains all these steps in detail. So I'll be sharing this particular documentation link also in the description box, and in this particular video also we are going to refer this particular documentation on. Okay. So here what we'll do first, we'll be launching one RDS instance, right? So here I will log into my AWS management console, and here I will search for RDS, and here I will go to database, and then here I'll click on create database, and here standard create we can keep, and here I can choose Postgres as the database type. The engine version we can choose the default whatever it is providing. Production dev test free tier, so as of now I can choose free tier 1. The database instance identifier database 1, or maybe we can write database demo YT1. So I'll be basically keeping this saved somewhere. So here in this notepad I have basically noted down the steps to be implemented. So here I will be putting this particular thing as instance identifier. Okay, cool. Now let's go to the next step, what we have to do. So here we are having master username. I'll be copying that and save in my notepad++, master username, and that is Postgres. Okay, cool. We can change if it is needed. Then credentials self-managed. So here master password I can put something, and here confirm master password, there I need to put that same password whatever we have given here. And for future tracking I'll be basically saving that here also. So here I have given the password admin @123 ! You can provide any password based on your wish. Okay, cool. Now here DB instance class I can keep this T3 micro, that is fine because this is just a POC we are doing. So micro instance is fine. Okay. Now storage type, allocated storage, minimum is 20 GB. So minimum let it be. And we don't want to connect to some EC2 compute. So let this option be selected. Now virtual private cloud. So in this case, if you have some VPC created by yourself, you can choose that. Here I am choosing the default VPC provided by AWS. Okay. And the subnet group. So here within this particular VPC, we are having this particular subnet group. So that one is selected, let it be fine. And then public access, so I want to allow public access, and even this particular subnet is in public region. So let me just show you. So I'll go to AWS, and then here I will search for VPC, and then here this is default VPC ending with B8A6. Okay, so here I'll go to VPCs, and B8A6 is this one. I will click on that, and here if you see, all the subnets are attached to the route table which is having internet gateway access. Okay, so all these subnets are kind of public subnets, so not a problem. So we are launching our VPC in the public region because this is just a POC. We want to understand the integration or fundamental concept first, and then eventually when we'll move to development or production system, we can keep all the security checks and make it a secured system. Okay, so publicly accessible, yes. Now VPC security group. So here what I can choose, create a new security group. Okay, and name of the group, demo YT post DB lambda. Okay, so this name I can save it. So security group basically acts as kind of firewall type. So here we have created that. Availability zone, no preference, that is fine. We don't want RDS proxy. Certificate authority, let it be default one. Database port is 5432. I'll just keep that save. Database port we are having. Tags not needed. Password authentication fine. Performance insights not at all needed because this is just a POC. Additional configuration, here database name I can put lambda trigger from DB, something like that, and here I can give this DB name stored, and that is fine. DB parameter group, let it be as it is. Enable automatic backup, backup is not needed. Encryption not needed. And then maintenance, auto monitor, upgrade, maintenance also not needed as of now. And here it basically shows monthly cost estimated. So yeah, that is fine. And I will basically create the database. And here it is showing master password is invalid. At least 8 characters should be written. Okay, right. So I will just update this password. @ is not allowed. So admin is something like this I can write. Let's see whether this master password it will allow or not. Create the database, and since here our database is getting created, it is going to take few seconds. Till then we can go to the next step. So in the next step what we are doing, we are creating our lambda function. So I'll just quickly do that. So here what it is doing, suggested add-ons. So as of now it is not needed. Now here I will open AWS Management Console in a new tab, and I am going to create the lambda function which we will trigger from our Postgres DB. Okay. So create function, and function name trigger from DB RDS. Some name I have given, and Python 3.12 let it be, and I will simply click on create function, keeping all other properties default. And here I will update the code. It is a very simple code. All we are doing, we are importing JSON and import sleep from time module, and here we are printing the event, and then we are having a sleep for 2 seconds and we are returning the data. Okay, and I will simply click on deploy. It is updating the function and it is successfully deployed. Cool. So our lambda function is ready. Let's go to the next step. As part of the next step, we need to create the IAM role with lambda access and assign to RDS. And all the steps, whatever I have written in my Notepad++, are following this particular document. So here if you see, we need to create the IAM role, and here to this particular RDS Postgres instance, we need to provide the permission that it should able to invoke the lambda function, right? So this particular step currently we are going to do. So here I will open AWS Management Console in a new tab, and here I will go to IAM, and here I'll go to roles. So create role, and here this role I want to create for RDS. And here if you see this option, allow you to grant RDS access to additional resource on your behalf. So this option I am choosing. Click on next, and then here I will provide the lambda access. So only lambda invoke access is needed. As of now I can provide lambda full access for experimentation purpose. Then I can click on next. RDS trigger lambda demo white. So this is our role name. I'll be keeping that saved somewhere. and this is the one, and here I will create the role. So here if I search, here you can see this role is created, which is having the Lambda full access. Cool. Now what we'll do, we'll attach this role to this particular database. And here if you see, by this time, this status is available. That means our database is ready to use. So before starting the database usage, all I will do, I will add the IAM role with this particular database. So here if I scroll below, manage IAM roles. So here I need to search that particular role. So here the role what we have created is this one. I will copy that and I will search here. This one, and here feature, I want to basically allow Lambda, and I will simply click on add role. So currently here if you see, it is in pending state. Soon it will be in attached state. Just we need to wait for a few seconds, and by that time what we can do, we can go to the next step to proceed further. And here you can see the next step is connect with DB. So to connect with DB, here I am going to use SQL Workbench, and if you are not having SQL Workbench, I'll be sharing the zip file in the description box. You can download from there. So let me open SQL Workbench here. So here I am currently in the folder where SQL Workbench I have unzipped. And if you unzip this particular thing, here you will be getting SQL Workbench, and there you will be getting this application option. Just click on open. Okay. And here this particular screen will be coming. So first we will be creating a new group. So demo YT RDS, and I'll click on OK, and within this I can create some database connection. So here currently we need to choose our driver. So our driver should be PostgreSQL driver, and here it is throwing the error that the library for the driver is not accessible. So here if you want to edit, click on yes. So here what we need to do, we need to provide the library for Postgres JDBC driver. So we will download that and configure here. So here I will go to Google Chrome, I'll open it, and here I will search PostgreSQL driver. And here you can go to the first link, and here you can click on download, and here this particular download button you can press. And with this, our PostgreSQL jar file is downloaded, and we need to configure this in our SQL Workbench. So here I will just choose that particular downloaded file. I'll go to this PC, and from there I can go to downloads, and here if I scroll below, here this is the option. I'll click on open. Okay, right. So this one I can delete, and this is the one, and this is the sample URL how we should be setting up the connectivity, that also it is providing. Just click on open. So with this, our driver is configured. Now we need to provide the URL. So the URL format should be jdbc://postgresql:// host port and the name of the database. So we'll configure accordingly. So I'll copy this thing, and here I will paste it. PostgreSQL, here host name we need to configure. So host name we'll get from our RDS console. So here if I go to our RDS console, and connectivity, this is the endpoint. So this one I need to configure, and port is 5432. So that also I will update. So here host I will put that, and port is 5432. Okay, and the name of the database, so in this case the DB name is this thing, so I'll just update that here. Okay, so this became our JDBC URL, and the username password, so username is basically Postgres, and password is admins123 exclamatory mark. So we need to put these things in our SQL Workbench for connectivity setup. So here URL, I'll put the value, username is Postgres, and the password here, this thing, I'll be copying that, and I can click on test. So here you can see this showing connecting to the database, and here if everything is properly configured, it will show connection to this database is successful. So just click on OK, and here click on OK. So here you will be getting this kind of console, and here in the left hand side your database related objects like tables, views, procedures, triggers, etc. will be shown. So if I expand to the table section or trigger section, currently everything is empty. So now what I will do, I will add some code here. So here the SQL queries I have written. So I'll just copy all this and paste in our workbench, and let me explain the codes one by one. So here just to show you, if I execute select current database, it will be showing the Lambda triggered from DB, that particular database what we have configured, right? Now here, to set up the integration between Postgre and Lambda, so that from PostgreDB itself we can trigger the Lambda function, for that we need to follow certain steps, and these steps are properly configured in this particular documentation. So here if you see, install the Lambda extension. So for that we need to execute this particular step. So all these SQL queries basically I have written here, so I'll execute them one by one. So first here we are executing create extension if not exist AWS Lambda cascade. So I will execute that, and here you can see it is successful. Now here what we will do, let me show you a simple demo how to call our Lambda function. So this is the syntax. So in generic way we can say select start from AWS Lambda dot invoke and then AWS common dot create Lambda function ARN, and here we need to provide our Lambda function ARN and the region where our Lambda function is basically available. So here let's go to our Lambda function. So our Lambda function ARN is this thing. I'll be pasting that here, and the region where our Lambda function is configured is North Virginia region. If you see, this is the one, and North Virginia is nothing but our US East one, right? So that you need to configure as second parameter, and then whenever we trigger Lambda, some event we should be passing. So in that event, what are the JSON structure you want to pass, that you can mention this way. So here we are passing body as a key, and the value part is hello from Postgres. Okay, right? So this is the query I can execute. So I will just run it. So here you can see it started, and here we got the output, and status code 200, payload status code 200, body hello from Lambda. From where this particular payload is coming? This payload is nothing but coming from this particular place, hello from Lambda, and basically from our PostgreDB this Lambda function is triggered. Let me show you that also. So if I go to monitor section and I can click on few logs in CloudWatch. So here you can see currently it is 12:23 PM, and just now our Lambda function was triggered. If I expand the logs here, you will be getting this message whatever we passed from our Postgres system, that is hello from Postgres, that it has printed as event. Basically we have executed this code now, that print event in our Lambda function, that it is printing in CloudWatch logs this way. Okay, right? But point to be noted here, this particular way of execution is synchronous execution. Basically that means we are waiting for the Lambda function to complete its execution, right? Because here if you see, if I just execute this particular Lambda again, hello from Postgres second time, something like that, and if I execute, you will observe immediately the response is not coming. It is taking 2 seconds to print the response. And why it is happening? It is happening because here in the Lambda we have given sleep time for 2 seconds. And once the complete Lambda function is executed, it is basically returning this particular return statement, that is JSON.dumps hello from Lambda. So this way what is happening? It is a synchronous execution. Our SQL system need to wait until and unless our Lambda function execution is complete. But in most of the system, we might prefer asynchronous invocation. For example, from our Postgres system, we will trigger our Lambda function, but we will not wait for the Lambda function to be completed, because it might take 10 minutes or up to 15 minutes, right? So asynchronous invocation also possible, and that you can do using this way. The code is almost same. Only thing is, as extra parameter, you need to pass as event. That's it. Okay. So let me show you that particular execution. Earlier you have seen that when we are executing in synchronous manner, it is taking some time to print this particular response, and payload also it is printing because it is waiting for the Lambda function to be completed. And here now if I execute hello from Postgres async, you will see that immediately the Lambda function will be executed, and here message will be coming. So here the result set it is returning very quickly. That means this way of invocation is not waiting for the Lambda function to be completed. Lambda function is executed in the backend in its own time, right? So here I can refresh and show you the logs also is coming here. So here if you see, currently it is 12:26 PM, and at 12:25:53 it got triggered with hello from Postgres async. So this is our asynchronous invocation pattern. Okay. Now coming back to our requirement, here if you see, the requirement was whenever in our RDS table some data is inserted by the developer team or data analyst team or business analyst team, then our DAX should be running. So that means based on user insert query, our Lambda function should be triggered, and then it can trigger Airflow or any other system, right? So how to do that? That is, in any table, as soon as some insert query, update query, delete query, whatever is executed, if we want to do certain job, and here the job is basically we want to execute this kind of query. So that time we can take help of database trigger. That's why trigger is used, right? That it will continuously monitor a table, and based on certain table activity, it will do some other computation. So let's implement the trigger mechanism, and we'll be creating a table called inventory. Whenever insert query will be executed in this table, then our Lambda function, it will trigger in the backend using this particular query, right? So that will implement. So here, first we are creating this particular inventory table. Currently here we are executing 3 insert query, and due to these 3 insert query, our Lambda function will not be triggered, because till now on this particular inventory table, we have not implemented the trigger, right? Now here we are creating our trigger on this particular inventory table. So let's see the code and syntax. Create or replace function, invoke Lambda on insert, return trigger, and begin. So this is basically our PL/SQL syntax. Perform AWS Lambda dot invoke. That same way how we have invoked here AWS Lambda dot invoke. Then here AWS common dot create Lambda function ARN. It is same. And then here what we will do, we will update our function ARN in this particular place, and the row to JSON. So what input we should be passing to trigger the Lambda function, that also we have to configure in the trigger, right? So here if you see, initially while doing this single execution, we were passing body like hello from Postgres async, hello from Postgres second time, etc, etc. But when we are monitoring this particular inventory table, whatever business analyst team or data analyst team will enter, that entry, complete row, we should be passed to the Lambda function, so that based on that particular inserted data, the Lambda function do certain job, right? So for that, here if you see the second parameter, here we have passed row to JSON new. Okay, so new basically is having the inserted data, the new insert query, whatever the business analyst or data analyst team has executed, that data is available in this new variable, and that we are converting from row to JSON, because Lambda function will consume the event as JSON data only. So that's why we are passing row to JSON, and this particular trigger I want to execute in asynchronous manner, so I am passing event also, right? So this is our PL/SQL code, and this way we will be creating a trigger on our inventory table. So without any further delay, we will simply execute this code, right? So here our procedure is created, and here you can see in the left hand side in the database object also the procedure is ready, but the trigger is not yet created. So this is our procedure creation. Now to add this trigger on our inventory table, this is the syntax. Create trigger, call Lambda on insert, after insert on the table inventory. So you may implement trigger on update, delete, etc, etc. So in this case, whenever there is an insert in the inventory table, that time we want to trigger this particular procedure, right? So for that, here this is the code we are using. For each row, execute function invoke Lambda on insert. So this particular procedure will be executed for each function in our insert query whenever we execute in our inventory table, right? So let's implement this particular trigger, and that is done. Now what we will do, we will execute a simple insert query in our inventory table, and we'll observe whether our Lambda is triggered or not, and that we can understand from the CloudWatch logs. So here if I go to CloudWatch, here last Lambda trigger was at 12 PM 25 minutes 55 seconds, and currently it is 12:31 PM. So let's see. So ideally whenever we will execute this insert query, based on this trigger the procedure will run, and this procedure will call our Lambda function to execute, right? So here I will just execute an insert query in this inventory table, and here let's see what happens to our Lambda function. I'll just simply refresh, and here till now nothing came. So here you can see a new log stream is created, and if I expand that, here beautifully the same data came. If you observe our insert query, we have inserted product D 0 and 30, and here you can see product name is product D, quantity is 0, price is 30, and ID is 4. So this ID is nothing but an auto increment value, what is kind of acting like a primary key for our inventory table. So that also it is passing. So this is the beauty of implementing trigger and integrating Lambda with our Postgres system. So all we have done is we created a procedure which will trigger our Lambda function, and that procedure we are calling using the trigger whenever there is some insert query happens in our inventory table. And that way, whatever data analyst or business analyst team will enter as a insert query, that will be coming to our Lambda function, and then from that Lambda we can trigger our Airflow DAG based on that particular input, or we can call any other AWS service or perform certain tasks, right? So I hope you understood this particular RDS and Lambda integration. This is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.